So today's topic is total quality management. Although we know the definition of total quality management, we are formally launching the definition at this moment. Total quality management is a philosophy that involves everyone in an organization in a continual effort to improve quality and achieve customer satisfaction. You can earn, in addition to achieve customer satisfaction, that is, improve profitability of the company. So quality is related with the profitability of the company, and this is known as the strategic quality management. Strategic quality management means that you will improve the quality of the product to achieve the company's objective, and the company's objective is ultimately profit earning. This is not all, but without profit, no company can sustain in the market. That's why profit is one of the biggest pillars of organizational improvement or organizational development. So total quality management doesn't mean that you are maintaining every components of the quality. Rather, total quality management means that you working in the company are responsible for the quality of your output. You in a classroom is responsible for improvement of the quality. It is total quality. I am responsible. Similarly, you are also responsible. And if you play your role, say for an example, if you do not understand anything, then you will raise the issue and then we will try to solve in the classroom. Then you will get the points and I will also be satisfied. So everyone, you the students, we teachers, the people who are helping us, say for an example, IT support system, they have also their role to quality control. If the IT system doesn't work properly, the people who are the helpers, who are always there in the floor, they are also equally responsible. So total quality responsible means total people in the organization is responsible for quality management. So once again, philosophy that involves everyone. Maybe you are thinking you are the operations manager, you are only responsible for the quality management. It's not true. Marketing manager is also responsible. The top manager, the CEO of the company, chief operating officer is also responsible for quality, because without the quality plan, the operations manager cannot do anything. So it is a holistic approach, or everyone is involved. Holistic approach in a continual effort. In a continual effort means that there is no ceiling of higher quality. Maybe today's quality is not the ultimate quality. You have to improve the quality. Improve the quality. It is a continual effort to improve the quality. And finally, if your customers are not satisfied, then you will lose the customers and the market equally. So customer satisfaction is most important. Otherwise, you cannot earn any profit. So total quality management means what? Total quality management means
when every stakeholder is involved.
Everyone in the organization is responsible. And the TQM approach, find out what the customer wants. So to improve the quality, the another name of total quality management is continuous improvement. Continuous improvement means that there is no ceiling of quality. You will improve the quality. Improve the quality. So TQM approach, or the steps of total quality management includes number one, find out what the customer wants. Customer needs, customer demands, customer wants changes over time. So first, you go to the customer, what they're demanding, and then design a product or service that meets or exceeds the customer wants. It means that design a product or service that meets or exceeds customer wants, what the customer are demanding wants. Try to give something more than what he is demanding. Then design process that facilitates doing the job right the first time. It means that the product or service design is coming from the marketing department. Now it is going to the production department, facilities department. Design processes, process design that facilitates doing the right job the first time. Then after designing the process, produce the product and keep track of records so that the product that you are producing in your process is giving defect-free output, and continue it and try to extend this concept to the suppliers. Suppliers means that according to Edward Deming, there are 14 points or 13 points, and one of the 13 points includes, one of the 13 point includes suppliers quality control. If the suppliers are not providing the quality input, you cannot produce quality output. So supplier is one of the important components. Supplier is the important components of total quality management. And the elements of total quality management includes number one, continual improvement. Then competitive benchmarking, employee empowerment, team approach, decisions based on facts, knowledge of tools, supplier quality, champion, quality at source, quality circle. So these are the elements that must have there in the company to maintain total quality management approach. Total quality management is also known as quality assurance. If we differentiate between quality assurance and quality control, we usually say TQM is quality assurance. Quality control means that you will produce the product, after production you will measure the quality of the product. That is known as the quality control. And quality assurance means that before bringing out the final output, you will check the quality of the process. Every step from input through output, you will check every step, and the output that will be bring out from the system will be defect free, quality full product. So total quality management we refer to quality assurance when we compare between the quality control and quality assurance. But in today's world, when the word TQM we use, it means quality control. When we are using the word quality assurance, we mean quality. So quality is a comprehensive word. The another name of TQM is known as continuous improvement. Another name of TQM is known as quality assurance. Another name of TQM is known as Japanese language, Kaizen. Kaizen is globally accepted word, and in your book, the word used to indicate TQM. So continual improvement is an element of TQM. Competitive benchmarking. What is competitive benchmarking? You will choose the industry leader. So when the private universities are thinking to adopt any learning management system, they refer to North-South University, because North-South University is the leader. How they manage the classroom, how they apply the learning management system, they check it. So competitive benchmarking means that a company will choose the best practices. That is known as competitive benchmarking. Then employee empowerment. Employee empowerment means that in today's world, employee empowerment and teamwork, team approach is almost same. Or the word we use is self-directed team. Can you remember the word self? Self-directed team. Self-directed team means that team is powerful to make decisions. Self-directed. So employee empowerment, self-directed team approach, or team approach is almost same. Employee empowerment, self-directed team. That means the people who are working in the company, they are self-directed. They have the power to make decisions. Decision based on facts. So statistical quality control or the quality control all are based on facts. In your forecasting chapter, if you can remember that you made forecast based on the previous facts, that means the decisions you are going to make will be based on the real facts. Without any data, you should not make decision. And the another name of decision based on facts is known as operation analytics. Operation analytics. Knowledge of tools. So the tools that you use must have knowledge of using those tools. Say for an example, some companies in our country, say for example, ports, CUATS, ports. Ports are using IoT devices with their machines. IoT device, Internet of Things. The devices can understand the efficiency of the machine, understand the efficiency of the worker, understand the efficiency of the total system, and they produce outputs instantly. And the manager who are supervising the facts, they can watch what is happening there in the factory, and they can they can watch the dashboard sitting at his office in a remote place. Knowledge of tools you must have, IoT devices. If your manufacturing facility is computer integrated, then you have to have the computer integrated manufacturing trainings. You have to have the supplier quality. Supplier must supply the qualityful product. And champion. Champion means, we are going to discuss about champion. Champion means you are choosing a project that is beneficial for the company. So when you are choosing a project, you are thinking whether it is a component of total quality management or not. Quality at source. Quality at source means that the quality, you are doing your job. You are a student, you are listening lectures, you are responding to the issues that is not clear to you. So if you do the job, then you are maintaining quality at source. Quality at source means that when you are doing your job, you are maintaining the quality of your job. That is known as quality at source. Quality circle. Quality circle means it is also equivalent to Deming's number 14 principle. Quality circle. Deming's number 14 principle. What is the number 14 principle? There will be a small group. The group will supervise whether the 13 other points are implementing in the company or not. So quality circle is a small group. They meet together to solve the quality problems in the company. So these are the elements of TQM, and total quality management is also known as continuous improvement philosophy that seeks to make never-ending improvements to the process of converting inputs into outputs. That means there is no ceiling of quality. Quality improvement or total quality means that you will improve the quality of the output continuously or continually. And Japanese word Kaizen is used for continuous improvement or also referred to as total quality management. Total quality management. And quality at source that we are talking. The philosophy of making each worker responsible for his or her work. That means you are a student. You have to make sure that you are a component of total quality management of the classroom. So you are listening to lecture, you are raising the issues that is not clear, and everything is making clear here in the classroom. It is known as the quality at source, the philosophy of making each people responsible for the quality for his or her job. It is known as quality at source. Who can tell me what is quality at source? Can anybody tell me what is quality at source?
Like the employees maintaining their quality of work, each
So
of them,
every people. What is TQM?
every stakeholder is
And what is the
responsible for-
relationship between TQM and quality at source?
Maybe it's the same.
Same thing, right? Elements of TQM. What we have said, it is one of the elements of total quality management and most powerful element. Quality at source or continuous quality or champion, or what we said is Six Sigma. It is also one of the important components of total quality management. Six Sigma. Statistically, Six Sigma means that there will be no more than 3.4 defects per million. So if you produce 1 million product, the defect will be only 3.4. It is also known as defect free or zero defect. Zero defect doesn't mean that it is zero. There will be no defective outputs. There may have, but the amount will be very insignificant. And the Six Sigma approach says that it will be 3.4 defects per million. Six Sigma. Conceptually, Six Sigma is a tool that is designed to reduce defects, requires the use of certain tools and techniques. So when we are talking about Six Sigma, we indicate that there will be 3.4 defects per million. We indicate that it is ultimately directing to reduce defects. We use several tools to reduce the defects. What are the tools? The Six Sigma tools includes, top management. Six Sigma team. It is one of the tools of Six Sigma. Six Sigma team. There will be a team in a company. The name of the team will be Six Sigma. And the team will have the members. The members are top management. Top management of the company are the members of the Six Sigma team. And the person who will be responsible for choosing a new project is known as the program champions. Program champions means the person who is responsible to choosing a best project. Then master black belts. Master black belts means that the person who are working in the team chosen by the program champions have sufficient statistical training. That is known as master black belts. So after finishing operations manager, you can be the master black belts because you have some quality, statistical quality management training. Although the statistical quality training has not been started in our previous lecture, statistical quality control will be the statistical approach of managing quality. And master black belt means the people, member of the Six Sigma team who has sufficient training on statistical quality control. And black belts means they are under the supervision of the master black belts. They are the team leaders. They are the team leaders, black belts. And green belt means that the members of the Six Sigma team and the lowest level members. So it is the hierarchical relationship. Black belts are the supervisors of the green belts. Master black belts are the supervisors of the black belts. Program champions is the supervisor of the master black belts. And top management is the supervisor of program champions. So this Six Sigma tool, if you choose a project using Six Sigma team, the project will be successful and the output that will produce from the system will be defect free. It is Six Sigma team. It is a tool of TQM, total quality management. Total quality management, the definition of the Six Sigma team once again is given here in the next slide. Champions. Who are the champions? Identify and rank potential projects and help select and evaluate candidates, manage program resources, and serve as the advocates of the program. That means the people who ultimately select a new project, champions. And master black belts means have extensive training in statistics and use of quality tools. So we are learning quality tools and we also learn some statistics in our coming lectures. And you will be the master black belts. Master black belts, when you are working in a Six Sigma team, you can identify yourself as the master black belts if you have extensive training in statistics and use of quality tools. And finally, black belts are the project team leaders responsible for implementing process improvement of the projects. They have typically completed 4 weeks of Six Sigma training and have demonstrated mastery of the subject matter through an exam and a successful completion of 1 or more projects. So that means they are also the important people and have some training on Six Sigma. And training on Six Sigma only doesn't mean the champions, master black belts, or green belts. Six Sigma ultimately indicates the program designed in the company that will produce defect-free output or continuous improvement, or it is a tool of total quality management. So if we review, what is total quality management? Everybody in the organization is responsible for quality, and if everybody do their own job, quality at source, they can produce defect-free output. And the tools of quality management include Six Sigma team. Six Sigma team is a team. The team ultimately is responsible for successful project management. And the members of the Six Sigma tools includes champions who identify the project, master black belts who have training on statistics and quality tools, Black belts, they're the trainer and have training on Six Sigma process, and green belts are the members who ultimately work on the floor, worker type of people. So Six Sigma and Six Sigma process, or Six Sigma, you can explain the Six Sigma through different models. This is one of the models, is known as DMAIC model for problem solving, and DMAIC means define, measure, analyze, improve, and control. So we are discussing about the total quality management. Six Sigma is a tool of total quality management, and under Six Sigma there will be, you can follow a Six Sigma process, and the Six Sigma process includes define the problem, measure the extent of the problem, analyze the problem, give a solution of the problem, and implement the problem, improve the quality, and finally control whether the improvement you have suggested is doing properly or not. So define, measure, analyze, improve, and control. These are known as the DMAIC. Define, measure, analyze, improve, and C means control. So if you follow the steps, you can make sure that the output that is going from the system will be defect-free. The more details version of the DMAIC is explained as the PDCA cycle or PDSA cycle. So it is also, the next one is also Six Sigma process, PDSA cycle or PDCA cycle. And PDSA means plan, do, study, act. PDSA. This is also known as PDCA cycle, plan, do, check, act. Same thing. So how it is related with the previous Six Sigma process or DMAIC process? Look at here. DMAIC process, and also, you know, PDSA or PDCA cycle is almost same. Plan, do, check, act, or define, measure, analysis, improvement, and control. So just a moment. Here, PDCA cycle applied to problem solving. The previous DMAIC approach is also applied for problem solving. And the problem solving means quality problem. Number one, plan. Plan indicates recognize the problem and determine possible solutions or causes. So plan includes recognize problem, form quality improvement teams, define problem, develop performance measure, analyze problem, and finally determine possible solutions. Recognize problem. Usually the people who are directly involved with the job or the process, they identify the problem. And if you can remember that there will be a quality circle. Quality circle means a small team in the company. They will handle the quality problems. So when any worker or people will recognize any quality problem, they will refer it to the quality cycle or quality circle. The quality circle will then, this is quality circle. Quality improvement team means quality circle. The problem will be referred to the quality improvement team. They will define the problem. Define the problem means, is it machine breakdown? Is it raw material scarcity? Is it worker related problem? Is system related problem? So they will define the problem after analysis and develop performance measures, and then they will try to the performance measure, analyzing the problem, and ultimately determining the possible causes. That means giving a solution of the problem. This is solution. And finally, problem, you have got the solution and now you are implementing solution. You are implementing solution and evaluating solution. After giving the solution, what is happening? Is it working properly? Or again, there is a problem, recognized problem. If there is problem, then go back to the quality team again. And if there is the evaluation says that the solution is perfect, ensure performance and then continue the improved version of the solution. It is known as plan, do, study, and act. This is also Six Sigma tool. Six Sigma tool. And also, usually from the statistics course, you know little about the quality tools. The operations manager can use this type of quality tools. The tools includes number one is flowchart. Flowchart means how the product is going through the system. Cutting, sewing, finishing. So cutting is done, then it is going to sewing. If there is any problem, then it is going back to cutting section. And it is going to the sewing section. Sewing, if there is any problem, then going back, if it is related with sewing, going back to sewing section. If it is related to cutting, then going back to cutting section. And finally finishing. And if there is any problem in finishing stage, what will happen? The product is defective. Product is defective and the product will be declared reject. So in every company, there is a production flowchart. And displaying production flowchart helps the manager to identify where is the problem and where the defect will be solved. Checklist, you know what is checklist? Checklist, this is also known as, tally system, isn't it? Checklist, these are the defects. Say for an example, this is machine defect, this is employee defect, this is raw materials defect. So how many machine defects are there in a week? Say for an example, first day, second day, there is no problem of a machine defect. Third day, there are 4 problems. Fourth day, 1 problem. C, employee related problem. First day there is no problem, 1 problem. Second day 4 problem. Third day 2 problem, and fourth day 4 problems. Usually these statistics help you to identify where is the problem and what is the frequency of the problem. And histogram is also a frequency distribution chart. Same here. A, B, C, D, E. So A, there is few defects, some of the figures. B, there are some defects. C, there are some defects. Say for example, A, there is only 1. B, there is 2. C, there is 3. D, there is 2. E, there is half problem. So when you are explaining the defects with the number of defects in a certain period of time, this is known as the histogram. And Pareto chart and histogram is same. It is also frequency and problem. It is also frequency and problem. X-axis is and y-axis is. So in Pareto chart, the maximum frequent item will be listed first. So C problem was had the highest frequency. So C is shown first, and then B is second highest. B is placed second, and third bar is third highest frequency of the problem. Finally E. So CBDAE, a diagram that arranges categories from highest to lowest frequency of occurrences known as the Pareto chart. So these are the quality tools the operations manager used to indicate how many problems, what are the problems have occurred there in the factory and what is the next step. You can also plot scatter diagram. The scatter diagram shows the relationship between the two variables. Relationship. You know how to develop scatter diagram and how to develop econometric equation. Also, control chart. Control chart can also be used as the basic quality tools. Control chart. What is control chart? Control chart means there will be an average line. Average age of the class 20. And there will be a lower control limit. Lower control limit. Standard deviation is 2 plus minus 2. So it is 18, 20 or 18. Your age is around 18, isn't it? 18 is the average. Minus 2 is the lower control limit. 16 plus 2, 20 is the upper control limit. It is known as the control chart. The operations manager used control chart extensively to control the process quality. The next chapters, chapter 10, is ultimately we will discuss about the quality chart. And it is the contribution of another Japanese professor known as Ishikawa. Ishikawa has developed a cause and effect diagram. Cause and effect diagram includes you will identify the problem and then you will identify what are the causes of the problem. These are maybe the causes are related with the people, maybe the causes related with the materials, maybe the causes is related to equipment, maybe the causes are related to methods. Methods. So it is look like a fishbone. Fishbone. That's why it is known as the fishbone diagram or cause effect diagram. A diagram used to organize a search for the causes of a problem, also known as the fishbone diagram. And you can identify the problem and what are the causes you can show. It is known as the cause effect diagram or the fishbone diagram. So total quality management means everybody is involved in the total quality management process. It indicates improvement of quality or continuous improvement of quality. It indicates quality at source. Quality at source means that when you are doing your job, you will make sure that the quality is perfect, and you will use Six Sigma process to ensure total quality management. There will be a Six Sigma team in a company. The members of this Six Sigma team will include number one is top management, number two is champions, number three is black belts, master black belts, number four is black belts, and finally green belts. Green belts. The Six Sigma process includes DMAIC, define, measure, analyze, control, and improvement for problem solving. The Six Sigma tools also includes, what do you call, what is the other method? Plan, do, check, act, or plan, do, study, act, PDSA. PDSA, recognize the problem, give a solution, then act, that means implementation of the solution, study whether the solution is fit or not, and finally, continuation of the improved solution is known as the act. Plan, do, check, act. And you can also use some basic quality tools. The basic quality tools includes Pareto chart, histogram, frequency distribution. Then a scatter diagram. If you are going to show the relationship between two variables, say for example, number of output produced and the defect items. What is the relationship between number of units produced and the defect rates? That is known as the relationship between two variables, and you can use scatter diagram to show the relationship. You can use the fishbone chart or Ishikawa's contribution. It is known as the cause effect diagram to control the quality in your company. Finally, we are going to discuss about the reliability. Reliability critical to quality. Reliability means that it is the probability that the product, service, or part will function as expected. What is reliability? It is the probability that the product, service, or part will function as expected. No product is 100% certain to function properly because there may be breakdown anytime. Reliability is a philosophy. Probability function. Reliability is a probability function depend on the subparts or the components. The example will make it more clear. Reliability of a system is calculated by reliability of the component system. Say for example, garments production system. You want to know the reliability of the garments production system. What are the components of the garments production system? Garments production system has three components for the moment. Number one, R1 is cutting. R2 is sewing. R3 is finishing. So to know the reliability, that means how much you are reliable that the product will be defect free. So are you reliable on cutting? If it is 100%, 1. Reliably for sewing, if you are reliable for 90%, it is 0.9. Reliability of finishing, that the finishing will be done perfectly, and the probability of doing the job perfectly is known as reliability of finishing. You will multiply it by the component reliabilities, and then you will get the reliability of manufacturing a product. The product will be defect free. And what is the probability? What is the probability that the product will be produced defect free? It is known as the reliability related to production or product quality. So reliability is the probability that the product that you are going to produce will be defect free, and we can calculate the reliability by multiply the parts. Assume that a product has two parts, both of which must work for the product to function. Part 1 has reliability of 80%, part 2 has reliability of 90%. Compute the reliability of the product. Multiplication of the two system. Now, can you give me a solution, everybody? Reliability of cutting, that means cutting will be defect free, is 90%. Reliability of sewing is 90%, and reliability of finishing is also 90%. What is the reliability of the system, or what is the reliability that the company, garments company, is going to produce a defect free output? Can you give me the solution or reliability of the system?
So we multiply all the reliability of the components
all
and
the component reliability. So 90%, 90%, 90%. What is the reliability of the garments production?
so 0.729.
So all of the slaving. What happens to the other?
So it's 0.721.
Point
729.
So why is 7 to 9 and why is 7? What happens? Mr. Fardin. 0.9 multiplied by 0.9 multiplied by 0.9 equals 7 to 9.
Yes, sir.
So are you getting, Mr. Jawadul Islam?
Yes, sir.
How to calculate the reliability of the system? We can calculate the reliability of system by multiplying the component reliabilities. All right.
Yes, sir.
Now, two power generators, the main and backup. There are two power generators. One is main power generator, another is backup power generator. Provide electricity to a facility. The main generator, NSC has the same system. They have their own power generation system and they are also taking support from the DISCO, isn't it? So the main generator has a reliability of 95% and the backup has reliability of 90%. What is the reliability or probability that the facility will have power? What is the probability? So it is not the component as like the previous one. The previous one, cutting, sewing, finishing, all are component, isn't it? But now here it is not the component. It is
Backup.
backup facility. When you are using backup, adding backup reliability or probability of function, then you will first original one plus dependency on the backup system. So reliability of the backup system is 90%, but how much support do you need from the backup facility? You have 95%, you are reliable on your original facility. All right. So 100% means 1, is it?
Yes, sir.
So 1
Yes.
minus 0.95, 5% only. You are 5% dependent on the backup facility. Are you getting? Because your original power source has 95% reliability. And for rest 5%, you are relying on backup facility, isn't it? Are you getting?
Yes, sir.
So 5%, you will take 5% of 90%. So 90% multiplied by 5% or 1 minus your original reliability. 5% of 90%. And the reliability of this system will be 0.995%. Are you getting the point?
Yes, sir.
So then can you solve it? An office security system at Delco, everybody do it. An office security system at Delco has two component parts, both of which must work for the system to function. Part 1 has reliability of 80%. Part 2 has reliability 80%. Compute the reliability of the system. What's the answer? 0.8 multiplied by 0.98. All right?
So 0.784.
0.784. Delco from problem 1 is not happy with the reliability of the security system. Now, security system, the part 1 has reliability, part 2, and has decided to improve it. The company will add a backup component to part 1. Part 1 has reliability of 80%. So they're going to add a backup facility to part 1 of a security system. The backup component will have a reliability of 80%. So backup facility, 80%. You are relying on part 1, 80%, all right? Now,
Yes.
the backup component will have reliability of 80%. 80%, how much do you need for the rest part or the backup part? 20%, is it?
20%. Yes, sir.
So 80% plus 20% of the
80%.
component, the 80%. Backup component will have reliability of 80%. So 20% of 80% is what? Are you getting, everybody? How I'm calculating the reliability of component 1, part 1. I am now calculating the reliability of part 1 because part 1 has backup facility. Backup facility. So what's the reliability of part 1?
80%.
80. You have 80% already, isn't it?
Yes.
80% plus 20% of the backup facility. 20%, 1 minus 80 is 20.
Yes.
So 20% of 0.80 is equivalent to 16.
0.16.
0.16 is the backup reliability, and main reliability is 0.8. Total is 0.96.
0.96.
And what is the system reliability? System reliability, there will be no changes in part 2. So part 2 reliability is 0.98. So 0.96 is the new reliability and 0.98 is unchanged. Are you getting? Part 2. Part 2 has a reliability of 98%. It is unchanged, isn't it? In second component, you are not happy with the part 1. So that's why you have added a backup component with part 1. Backup component will also have a reliability of 80%. The backup component will have a reliability of 80%. So you are already 80% reliable on part 1. And the backup facility will depend on 20%. 80% minus 100% is 20%. So you will take the 20% of the new backup component. New backup component is 80. 20% of 80% is 16%. So now part 1 has reliability of what? Are you getting? So part 1, we are dealing with the reliability of part 1. There is no changes in reliability of part 2. And you are happy with part 2, 98%. There is no change. Now you have installed a new facility, backup facility for part 1. And reliability, new reliability you are calculating here. You have 80% reliability, 80%. All right. 80%
Yes,
you
sir.
have, or 0.8.
0.8.
Plus you need more.
Point-
1 minus
0.8.
80%. Because you have already 80%. 1 minus 80%, is it?
Yes, sir.
Is equivalent to.
Oh, 0.2.
And what is the reliability of the backup facility? The backup
0.8.
component will have 0.8 multiplied by 0.8
2.
will be
It's 0.16.
0.16, isn't it?
Yes, sir.
So what is the new reliability of part 1?
0.96.
0.96. Then the question is, what is the reliability of the improved security system? What is the reliability of the improved security system? What is the reliability? Part 1 has reliability of 0.96 here, 0.96,
Yes.
and 96 will be multiplied by the part 2. Part 2 has
Right.
98%.
0.98.
98%, and the total result will be
0.9408.
0.9408. Everybody is getting the point? How to calculate reliability of the system? If the system has no backup facility, then multiplication. If the system has backup facility, then the backup facility will be calculated, and it will be calculated by using 1 minus existing facility, your dependency. Maybe solution is here.
Sir, the class time is over.
Yes, my class time is over. Also, lecture is over. Lecture is over.
স্যার আমি স্যার যখন আপনি অ্যাটেন্ডেন্স নেন স্যার তখন স্যার নেটওয়ার্ক ইস্যুর জন্য স্যার অ্যাটেন্ডেন্স দিয়ে পাইনি স্যার।
So if we review to the, okay, we can discuss the attendance issue now. But before that, we are finishing the lecture. Those who have already confirmed your attendance can leave the classroom. Thank you for today.
Thank you, sir.
Okay. So, attendance, is it?
Yes, sir.
So, who needs attendance?
স্যার
Sir,
ফার্স্ট দিন
Salman Islam Rida.
আমি স্যার চ্যাটে লিখে দিয়েছিলাম স্যার।
স্যার আমাদের মিট কি তাহলে স্যার 28 তারিখ হবে?
I think it's better.
স্যার তাহলে স্যার
Sir,
সিলেবাস কি স্যার আজকে যতটুকু পর্যন্ত স্যার পড়ানো
আজকে
হয়েছে?
পর্যন্ত যেটা বললাম এই পর্যন্ত কোয়ালিটি।
আচ্ছা স্যার কোয়ালিটি স্যার নেক্সট ক্লাসে কি তাহলে স্যার একটা টোটাল ওভারঅল রিভিউ হবে স্যার মিড টু এর সিলেবাসের উপর নেক্সট ক্লাস?
নেক্সট
মানে
ক্লাস,
কি কি
next class Tuesday. Yes,
Yes,
we
sir,
can
sir.
give you a revision.
ইয়েস স্যার তাহলে একটু হেল্পফুল হয় স্যার কোন কোন
Yes,
টপিকগুলো
we
ইম্পর্টেন্ট।
can do that.
ওকে স্যার
So if you agree that you are gonna sit for the exam on 28th, then we can have a review on our coming lecture.
sir,
Yes,
will you be checking out the attendance again? Because I have a class after this and I need to run.
yes, I am trying, but the internet is so slow.
Because sir, আমার এটার পর আপনার পর একটা ক্লাস থাকে তো, so that ma'am একটু punctual.
I'm trying. You can leave.
Sir, sir, I had a
Yes.
question about the group project, sir.
Project,
As we
yes,
have,
yes, those who don't have any class after my class, then you can wait here. We can discuss about the project.
sir, we have submitted the project proposal, right? So, sir, we haven't gotten any approval from you yet, like whether we will proceed with this company or not.
Approval, what I have said. I've said that the company you have chosen is all right, because any service or manufacturing or commercial, anyone is perfect. That's why it is, allowed to do your next step. All right.
Okay,
So when you are gonna submit the progress report,
so we already did yesterday.
that's fine. Then progress report, finally, I'll check after final submission. And I will give some comments, and you will incorporate these comments before presentation. So as
Okay.
the progress report has already been submitted, maybe this time I will give comments on your progress report online. All right.
Okay.
So can you please identify yourself here?
Sir, I'm Zarif.
Late attendance.
Oh, okay.
Sir, Niyam Ashraf. It's 2211 batch.
Niyam Ashraf.
Yes.
Then who's left?
Salman Islam Rida.
Mr. Hriday.
Sir, Samin here, sir.
Sir, Fardin MD Rizwanul Haq.
Just a moment. I'm still searching Mr. Hridoy. Heart touching. And then
Sir, Fardin MD Rizwanul Haq.
can you identify yourself here?
Sir, Samin here, sir.
Samin. Samin, yes, sir. And Rizwanul Haq.
Yes, sir. Fardin MD Rizwanul Haq, sir.
Yes. So anybody left?
I guess no.
Okay, thank you.
Sir, I had
Yes.
one last question. Sir, one last question. Sir, sir, at this moment, if I think that I want to change my company that I selected, can I do that?
You can do that, but maybe it will be pressurous for you. However, if you can continue your job with a new company, you can do that, no problem. Because there is relaxation for you. You can do that. You can change it.
Yes, sir. Okay, sir.
So any other issues?
No, sir. Thank you, sir.